Okay, you're given this system of three equations, three unknowns, asked to solve the system using Gaussian elimination with partial pivoting. Okay, so I'm going to go through this pretty quickly. Pause the video and take notes when you need to. Here's the original augmented matrix with the coefficient matrix on the left and the constants in this fourth column. And if you're going to use partial pivoting, you'd like to examine this first column and make sure that the rows are in order so that we go from highest absolute value to lowest. So we have to interchange row 1 and 3 to get to here. And the idea is to get zeros right here. Okay. And what we're going to do is figure out what number to multiply the first row by in order to make this -3 a 0. And that's kind of what I've done here. A lot of textbooks say to subtract after you've multiplied, subtract the result from row 1 to get 0. I like to just say, I'm going to take this -3/7 times 7. That would give me a -3, but I want a +3. So I just use the opposite of whatever element we're turning to 0, divided by the number up here. So that's -3/7, but take the opposite. So 3/7 times 7 plus this element gives me the 0 that I need right here. And now I have to figure out what the rest of the elements become as I multiply the first row by 3/7 and then add it to the second row. So here's what that second element becomes. 3/7 times this 2 plus 1 is 13/7. 3/7 times this -8 added to this 5 means this element becomes 11/7. And 3/7 times this 2 plus a -5 becomes -29/7. So there's the new second row. Notice that the first row remains intact. And now we want to turn this element to 0. So think, well, 2 divided by 7 would be my multiplier, but take the opposite. So -2/7 times 7 added to 2 gives me a 0 because the 7's cancel out. So let's do the rest. -2/7 times 2 added to 5 is 31/7. -2/7 times this -8 added to 7 gives me 65/7. And finally, -2/7 times this 2 plus this 3 gives me 17/7. So there's the new third row. Now we're ready to try to turn this element to a 0. And if we're going to use partial pivoting, we want these two elements to be in descending order as far as absolute value goes. So we interchange row 2 and 3. Now we have to turn this element to 0. So let's go to board 2 to see that happening. How do we turn this element to 0? We divide this element by this element and take the opposite. So -13/7 times, if I divide by 31/7, that's the same as multiplying by its reciprocal. So there's your multiplier. -13/31 times 31/7 added to 13/7 gives us the 0 that we need there, but then we have to adjust these two elements right here. So -13/31 times 65/7 added to 11/7, it's -72/31, and so on. There's that final element. So now we're ready to use back substitution. This is x3 right here. It equals, this is the coefficient of x3. So -72/31 times x3 equals -160/31. Solve for x3 by multiplying both sides by the reciprocal of its coefficient. That reduces to 29ths. So x sub 3 is 29ths. Once we know that, we can move to the previous row, 31 sevenths times x sub 2 plus 65 sevenths times, we know x sub 3 now, 29ths. Solve this for x sub 2, and it turns out you get negative 37 ninths. I'll leave finding the value of x sub 1 to you, but we'll say 7 x sub 1, 2 times negative 37 ninths is 20 ninths equals 2. There you go. Hope that helped. If you have any questions, post a comment.